Hey guys, welcome to another video. Today we're going to be talking about some algebra, and specifically we're going to be talking about solving equations. What does this mean, solving equations? So if you've got your basic arithmetic down, in other words, if you're good with your addition, subtraction, multiplication, division, as well as your order of operations, we can begin. I'll do a quick review of this. So when you have a number of operations in an expression, let's say we have something like 6 plus 3 times 2. But then let's say we also have and then this is all divided by how do I go about this? This is like a pretty nasty mathematical expression. Well, I just do what this is saying, right? It's just saying start with anything that has a parentheses around it. And notice how we have like a double parentheses going on here. We always start with the innermost parentheses, dissolve the parentheses on the inside by evaluating what's in here, right? And then we just work our way outwards. So we start with the innermost parentheses, which would be this part, and then we'll work our way out. All right, so, well, with that said, what do I write? Okay, well, I'm going to dissolve this inner parentheses, right? So it's going to be 6 plus whatever this is. So that's 3 times 2. That's going to be 6 plus 6. Now I still have these outer parentheses, so I'm going to keep these here. And then we're going to do plus 9 times, what's 6 minus 8? We want to evaluate this before anything. It's negative 2, right? And we can see that just on our number line if we have 0 here. And we have 6 here. Well, if we go minus 8, that means we've got to move 1, 2, 3, 4, 5, 6 to get to 0, and then 7, 8, that's negative 1, and negative 2, that's where we end up. That's where I get this negative 2. Okay, and now I'm going to do my division line, and then we're just going to write 8 plus. So 4 is just by itself, and it's just like placed next to the 6. Whenever two numbers are next to each other like this, we just multiply them. Just imagine a little multiplication symbol or a dot, multiplication dot. So X, or the cross and the dot, are both valid multiplication operators. And so A times B just equals AB. Yeah, so 6 times 4, what is it? It's 24, right? So we do multiplication before we do addition. It says it right here. And now let's just look at the top first. Let's look at the top of the fraction first, and then we'll look at the bottom. We'll just work our way from left to right. So here we have 12, and then plus, we get a negative 18 here. Okay, and then draw our division line, and then evaluate what's in the bottom. So what's 24 plus 8? Well, I know that it only takes 6 more to get to 30 from 24, and 8 is only 2 more than 6. So if we use 6 to get to 30, and we go 2 more, that means we're going to get 32, right? Now we have one more step. Let's evaluate this right here. When you add a negative number, That's the same thing as just subtracting that number. Subtracting the positive version of the number. So I can rewrite this as 12 minus 18 divided by 32, okay? What's the difference between 18 and 12? It's 6, right? But we're subtracting a larger number from a smaller number. So the result is going to be less than 0, or negative. So we said the difference is 6 and it's negative. And then 32. All right, so how can I break this down? Is there any common factors that I can use to simplify this? I think probably I can divide both the top and the bottom by 2, right? And so when I divide the top by 2, negative 6 divided by positive 2 is negative 3. And then 32 divided by 2 is going to be 16. And we have correctly evaluated this using the proper order of operations. All right, so now let's get to solving equations here now that we have a good idea on the order of operations. What I want to do is I want to say that I'm going to give an equation, and equation is indicated by having this equal sign. 2x equals 18, right? So I notice if I want to solve for x, so I'm asked solve for x, that means I have to say what x value does this need to be in order to make this statement true? Right? So what does x have to be? What must x be? What must x be? Well, one thing we can do is we can notice that right here, this is multiplication that is happening. And we want to get the x like by itself. We want to have like x equals some expression, some mathematical expression. Eventually we want to say x equals some value, some number. Well, if this is multiplication, to undo multiplication, we divide. So what I'm going to do here to get x by itself is I'm going to divide it by 2. And whatever I do to one side of the equation, I must do to the other side of the equation. Otherwise, we end up changing the equation, and it doesn't mean the same thing that it originally did, and we'll get the wrong answer. Looking at this, do you see anything that cancels out? If you guessed that these 2's cancel out, you're absolutely correct. If you remember from your algebraic identities that any number over itself is just equivalent to 1, right? So any number over itself is equivalent to 1. That means that these will cancel out. And that's just now the same thing as 1 times x equals 18 divided by 2. All right. How do we, and then anything times 1, we can just drop the 1, because anything times 1 is just itself. That's another identity that we learned. Any number times 1 is itself. And what's 18 divided by 2? Well, one way you can do this is count to 18 by 2's and count how many 2's are in the 18. Right? So if I count this on my fingers, I have 2 plus 2 plus 2. That's 3 2's. Plus 2 plus 2. So count it on your fingers. 2, 4. I'll tally it. 2, 4, 6, 8, 10, 12, 14, 16, 18. Right? So we have 9 pairs of 2's in 18. So x equals 9. We've got x by itself. The cool thing about this is, okay, we started out with 2x equals 18. If I can check my solution. So I said x equals 9. Well, I can just plug in x equals 9 right here. And if this results in a true statement, then I have the correct solution. The solution is correct. And in fact, so I plug in 9 right here. I say that this is 2 times 9 equals 18. Does it? I don't know. Let's count. 2, 4, 6, 8, 10, 12, 14, 16, 18. Is this 9? I think that this is 9, and I think that our statement is correct, and we have ourselves an identity. I want to do one more, and we're going to just kind of blast through this one quickly. If you can, I want you to pause the video, and I want you to solve it on your own. Okay, so I need to find one of these good examples here. Yeah, so we're going to make it a little more complicated now. So I'm going to say solve for x. And then we will have the equation. So what you're going to want to do is get x by itself. And then you're going to want to, you'll get the value for x. So go ahead and work this out, pause the video, and I'm going to start working at it right now. Here we use the distributive property. And so we're going to say that this is 3x times 6 plus 3x times 4 divided by x. So that's just distributing the 3. That's not, we're not changing anything yet. We're not multiplying anything by both sides of the equation. I'm just simplifying the expression that we have. And I do that by using the distributive property. Remember the one that says that A times B plus C equals AB plus AC, because A is distributed. So you go A times B, and then you go A times C, and you add those together because of the addition sign here. Okay. And now I'm just going to simplify this a little bit more. What's 6 times 3x? It turns out to be 18x. And then this one's a little more tricky, but if you understand the multiplication of fractions, this should be no big deal. Basically, what's happening here is I'm saying 3x times 4 over x, right? Well, 3 times 4 is just 12. And then I already said that any number over itself is just equal to 1. So that just cancels out. It's basically like saying 12 times 1. Okay, and then we also still have this equal sign and a 9 over here. I'm going to rewrite this with everything that we have. So I have 18x plus 12 equals 9. All right, first thing I want to do here, now that we have the equation in a pretty solvable form, is I need to get x by itself, right? So I need to start chipping away at this thing. I'm going to leave this term alone for now, and I'm going to take the one that doesn't have an x in it, and I'm just going to collect it on the other side of the equation so that we can get as few terms as possible before we start solving. So that turns into 0. 9 minus 12 is negative 3, right? And 18x, we left it alone. We just drop that down there. And then we bring our equal sign down and our plus sign down. We don't need the 0. We have 18x equals negative 3. What do I do now? We saw this before. This is multiplication. How do we undo multiplication? Undo it by dividing, right? And since we need to get x by itself, we're going to divide by the thing that it's being multiplied by. Divide by 18 on both sides of the equation. A over a equals 1. And then we divide it over here. This actually simplifies to what? Negative 1/6. So our final answer is x equals negative 1/6. You'll actually find that if you plug in x equals 1/6 to our original equation, it will result in a true statement. And in fact, I'm actually just going to do that right now. 18x plus 12 equals 9. Okay, well, x equals negative 1/6. So, and then I will say, does, we're testing, right? So I'll put a little question mark here. 18 times negative 1/6 plus 12 equal 9. Does it? This is more like a question. I'm like, does it equal that? All right, so what's going on here? I can just multiply. This is like 18 over 1, right? And when I multiply fractions like a over b times b over c, you end up getting like ab over bc. And that's not actually a really good way to put it. I should say a over b times c over d equals ac over bd, right? A times c over b times d. With that in mind, we can do this. And I can say 18 times 1, what is it? Negative 18. 1 times 6. 6. Positive. Plus, bring everything else down, equals 9. Does it equal 9? I don't know yet. What else can we do here? We can simplify this. How many times is 6 going to 18? Count on your fingers. 6, 12, 18. Goes in 3 times, right? And we have this negative sign divided by a positive, so that's going to result in a negative number. So it's negative 3 plus 12 equals 9. Take it one step further, since we have a commutative property of addition, right? Commutative property. It means that we can just switch the order and it will not change the result. So I'll say 12 minus 3 equals 9. Does it? Well, if we start with 12, right, and then we take away 3, so delete those two plus 1 more, which will just leave us with 4 in this one. This is in fact 9. Our equation checks out. We got the right solution, and x does in fact equal negative 1/6. So that's how you solve a basic algebraic equation. We'll go over some more complicated examples in the future, but I thought this would be a good introduction to the topic, just to kind of let you guys get a feel for what the rest of the subject is like. So with that said, I'll wrap this video up right now, and if you have any questions, just leave them in the comments. If there's anything that you would like me to cover in the future, I would be happy to oblige. Have a great rest of your day.